The problem we are given is that two objects are resting on a rough plane at 20 degrees to the horizontal. Now, an object with a mass of 1.5 kilograms is hanging off the end of the plane, causing constant acceleration. One object on the plane has a mass of 0.8 kilograms and the other has a mass of 0.5 kilograms. Consider the pulley to have minimal friction and the coefficient of friction to be 0.25. The problem is to find A, the acceleration of the system, and B, the tensions of the first tension and the second tension. Here we see in the diagram that there is a turtle, labeled mass turtle, on the end of an inclined plane which is set at 20 degrees as the problem said, and the turtle is attached to mass 1, which is 0.5 kilograms, and then strung over a pulley upon which mass 2 is also attached, and mass 2 is 1.5 kilograms. So you can see we are having to solve for acceleration going down on the mass 2 and tension 2 and tension 1, and we can see due to the diagram that the mass of both objects combined, which is the turtle 0.8 kilograms and the mass 1 0.5 kilograms, is going to be 1.3 kilograms and called mass both, or mass B. So in this problem we can see that to solve for acceleration we have to cancel tension, which is the second unknown, and to do this we must find two equations that both have variables. The first equation will contain all the forces acting on the hanging object, where the acceleration slows the descent due to gravity. In the second equation, the forces acting on the two objects combined that are on the plane are described, with tension against the force of friction and gravity in the x direction equal to the acceleration in the system. To cancel tension, we can set both equations in terms of tension, then set the two equations equal to each other. So you see the first equation for tension is tension equals the force of gravity times the second mass, all of that minus the force due to acceleration times the second mass. And then we have our second equation for tension, which is the force due to acceleration times the mass of both objects, plus the force of gravity in the x direction times the mass of both objects, plus the force of friction times the mass of both objects. And then you just set those equations equal to each other to get rid of the tension value. We can now continue to set the combined equation in terms of acceleration. Here we have the force due to acceleration times the second mass, plus the force of acceleration times the mass of both objects, plus the x direction of the force of gravity times the mass of both objects, plus force of friction times mass of both objects, and all of that is equal to the force of gravity times the second mass. And then to isolate the force of acceleration, you simply remove the force of acceleration from the first part of the first equation, and you get the force due to acceleration times mass 2 plus the mass of both. And that will be equal to the force of gravity times the second mass minus the x direction of force of gravity times mass of both plus force of friction times mass of both. And that'll finally get you an equation where your force due to acceleration is isolated. So the next step is to find the combined mass on the plane and the force of friction in the x direction in the plane, as well as the friction on the plane, so the coefficient. And so the first equation is that the mass of both objects is simply equal to the mass of the turtle plus the first mass. And the mass of the turtle is given as 0.8 kilograms, and the first mass is given as 0.5 kilograms. The mass of both objects is simply the mass of turtle plus the first mass, and that's equal to 1.3 kilograms. So you can substitute values into the equation and get that Fgx times the mass of both equals the mass of both times gravity times cosine theta, and theta is given as 20 degrees, and we already know that the mass of both is given as 1.3 kilograms. And so force of gravity x times mass of both objects finally equals to 11.97 newtons of force. And then you have that the force of friction times the mass of both objects is equal to mu normal force. And we know that the normal force is equal to the force of gravity in the y direction, or mass of both times g sine theta. and we know that mu is equal to 0.25. So the force of friction times the mass of both ends up equaling 1.09 newtons. With the values we found in the previous steps, we can substitute them into the derived equation for the force due to acceleration and then solve for the acceleration. So you simply substitute in all the values into the equation, and the end result is 1.36 meters per second squared. So our next step is to find the tension over the pulley, and we can use one of the original two equations in relation to tension to solve for tension with acceleration. So we have the equation for tension, which is force of gravity times the second mass minus force due to acceleration times the second mass. And we know that the second mass is equal to 1.5 kilograms, and we know that due to the last step, that force due to acceleration is equal to 1.36 meters per second squared. So we have all the values we need to substitute into the equation. So 9.8 meters per second squared goes in for the force of gravity, and the second mass is 1.5 kilograms, just substituted in, minus 1.36 meters per second squared, substituted in for the force due to acceleration, and finally mass 2 again, 1.5 kilograms. And when substituted into the equation, you get that the second tension is equal to 12.66 newtons. The tension between the two planar objects can be expressed as a proportion of the force of the tension across the pulley, where the lower object at 0.8 kilograms takes 8/13 of the force in the original tension. And this is due to the distribution of the tension over the objects. And so our first tension is equal to 8/13 of the tension, and 8/13 is the proportion of the original force that is expended by the second object, which is the mass of our turtle. So the first tension is 12.66 newtons. If you multiply that by 8/13, you get a final answer that the first tension is equal to 7.79 newtons.